When you first study physics, the sheer volume of new terminology is overwhelming. Suddenly, you are expected to navigate a world of joules, newtons, watts, and pascals. The experience often feels like trying to memorize a massive, disconnected glossary of quantities and equations just to keep up. But consider the possibility that this list is an illusion. It may be that every complex measurement is actually built from the same handful of simple, foundational blocks. Identifying this underlying pattern is the true starting point for physics. It allows you to move past memorization and begin looking at the structural logic of the universe. Everything starts with base quantities. These are standardized reference values, like the kilogram, that scientists have agreed upon as the foundation for all other measurements. While there are 7 of these base units, the study of mechanics relies almost exclusively on just 3: length, mass, and time. To indicate we are discussing the major of these quantities rather than their value, we enclose them in square brackets: L for length, M for mass, and T for time. These brackets signal that we are ignoring the numbers entirely. We don't care if a measurement is 5 meters or 5 light years. We are only interested in its identity as a length. We can test this method by deconstructing a common measurement, volume. To find the space inside this box, the standard geometric formula requires multiplying its length by its breadth and its height. However, breadth and height are just different names for the same physical property. Fundamentally, all 3 are simply a quality of length. By multiplying these 3 dimensions together, we find the signature for volume. It is simply length cubed, or L to the power of 3. Since mass and time play no role in defining volume, we account for them using 0 as an exponent. This shows they are entirely absent from the calculation. Regardless of the shape or size of an object, every measure of volume in the universe eventually reduces to exactly 3 dimensions of length. To push the theory further, we can analyze a more interactive concept: force. In physics, force is defined as the product of mass and acceleration. Mass is one of our base units, so we can immediately replace it with its dimensional symbol, m. Acceleration is more complex. It measures how velocity changes over time. Because velocity is just length divided by time, acceleration becomes length divided by time again. Expressing those terms as symbols gives us mass times length over time squared. By using a negative exponent, we can move the time variable to the top of the expression, revealing the final dimensional signature for force. This proves that even dynamic interactions are just specific mathematical arrangements of mass, length, and time. The true value of this technique is revealed when we look at how it simplifies our vocabulary. Think about 3 terms that sound very different: initial velocity, average velocity, and raw speed. In the real world, these describe different scenarios and use different numbers, but they all describe the same basic action: a length covered over a certain time. Because the foundational action is the same, all 3 terms collapse into an identical dimensional signature, L t to the minus 1. Dimensional analysis acts as a translator. It groups concepts that are structurally the same, regardless of the names we've given them. This is the primary foundational rule of the physical world. Dimensions are indifferent to specific magnitudes or situations. They focus entirely on the fundamental type of quantity being measured. This technique reveals the internal logic governing physical behavior. An understanding of these 7 base quantities provides the tools to deconstruct and verify any equation in the universe.